So today's lesson is on the product and the quotient rule. So we have about 4 problems that we'd like to go through here, all of varying degrees of difficulty, just so you can kind of see a little bit of how we work with the product and the quotient rule. So the first one starts off with a trig function, and we're trying to take the derivative of the product of tangent w times sine w. So what we have to first remember is that the product rule itself, given 2 functions, let's say let h of x equal f of x times g of x, the product rule says that the derivative of this function will be the first function times the derivative of the second function plus the derivative of the first function times the second function. So we're going to try to pull that off here. It really doesn't matter which one you make the first function or the second function, and it also doesn't matter the order in which you write this out in terms of does this expression come first or that one, because it's addition, it's commutative. So in order to get our derivative here, and the notation here would be the derivative of y with respect to w, according to our definition, would be tangent of w times the derivative of sine of w. So that would be cosine of w. Then we'd be adding to that the derivative now of tangent, so that would be secant squared. And then we'll be multiplying that times the original function sine of w. Now, as far as simplification is concerned, if you see an opportunity to do something simple, I would do it. If not, I wouldn't worry too much about it. This is 1 over cosine squared, so I don't think we want to create a fraction here. This I could do. This tangent is sine over cosine. So technically, if I made that sine over cosine, right, those would cancel. So don't be surprised if you find a final answer of sine of w, oops, and then plus that. Now, technically, you could even go a little further, which we won't get into right now. You could technically pull out a sine of w, perhaps look for some type of a trig identity, but we're just going to leave our answer like that. Okay, let's look at a second example now with the quotient rule. Now what I did in this problem was I tried to embed the quotient rule within another problem. So looking at it at first glance, yes, you could do the product rule because you have one expression being multiplied times another. But I think it'd be a little bit neater and a little easier if we just kind of distributed here and made that a little simpler to start off. So that would just give me 2t on the front end, right? And then minus t squared over t plus 1. So this is where I'm going to need to use the quotient rule, not here, obviously. So the quotient rule, remember, let's say we have h of x, and this time h of x is defined as one function over another. Then the derivative would be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's do that here. Now first off, when we derive s here, we're just going to get 2 to start off, right? The derivative of 2t is just 2. So that part is easy. But now we have to subtract from that the derivative of that quotient. So we're going to execute our rule here. So that would be, sometimes we say low times the derivative of high. So that would be 2t minus high times the derivative of the low function, the denominator. And we're going to put all of that over the bottom squared. And just like our last problem, if we could try and simplify, we would. So here we're going to do a little bit, see where that gets us. Clean it up just a tad. So we're at 2 minus, and here it looks like we could do 2t squared plus 2t minus t squared all over that. And combine a little bit like terms here. I don't even know that we need to factor per se. So I'm going to leave my final answer as this. S prime of t is equal to 2 minus t squared plus 2t all over t plus 1 squared. So now that we know the product rule and the quotient rule, and those are only 2 examples, but now that we've seen them, that does allow us to do a couple other things. So let's look at our third problem. So we know that in the past we've written equations of tangent lines to curves, and so now all that changes is we can use another derivative rule in order to do the same thing. So we always like to keep our equation of our tangent line something like this, right? Y minus y1 equals the slope at some value, right, times x minus x1. So obviously we have 2/3 of this answer already. We already have 4 and 7, so we're good to go there. We don't have the derivative though at 4, so we're going to have to go do that. And you can see we have a quotient, so we're going to have to derive that. So let's go ahead and do that. So here we go again, low d high minus high d low all over the denominator squared. Now, in the last problem, I simplified a little bit, and here we could certainly do the same thing. I don't necessarily do that all the time when I know I'm going to be plugging a value in. So here I'm going to be substituting 4 in for all the x's. So I think I'm just going to do that right from here instead of trying to simplify it, because my end result is I really just need the number, right? So we're going to evaluate this when x equals 4. So f prime of 4, let's see, 4 minus 3 is 1, so we'd have 1 there. 4 plus 3 is 7, right, over 1 squared. So it looks like -6 is my slope. So my final tangent line equation, y minus the y coordinate, equals the value of my derivative times x minus the x coordinate. So nothing new in terms of the question they're asking here, but the only new piece is now we can use the quotient rule to actually derive a function. That's really it. So now we're looking at this last problem where we have to find the second derivative of a function. So we're going to have to do the product rule. You can tell here we have one function times the other. But then watch what happens when we get to that and we have to go one step further. So let's start off here. G prime of x will equal, okay, the first times the derivative of the second plus the derivative of the first one times the second. Now what you have to watch out for here, don't think that this is x squared minus sine x. It's really not. It's just multiplied. I don't even know if I would clean that up. I mean, we could bring the negative out there. But the real focus now is what they ask. I need to get a second derivative, which means I need to derive this one more time. So in order to do that, watch what happens here. Now we are going to have to execute 2 different product rules, right? So this one will be the derivative of x squared, let's say. Or I've been saying, let's do x squared here, now times the derivative of that, just to stay consistent with the video, what we've been doing here. Plus, now we take the derivative of x squared times the original function here. Okay, that takes us through the derivative of that product. Now, meanwhile, we have to find the derivative of that product. So, 2x times the derivative of cosine plus 2 times cosine. So watch what happens. Here we have one product rule being initiated. Here we have the other one. And at this point, it's just about simplification. All we have to do is clean up. So let's see if we can maybe even find some like terms here. So I see here we have negative x squared cosine of x minus 2x sine of x minus another 2x sine of x, and then finally plus 2 cosine of x. So the only thing it looks like we might be able to combine is that. So my final answer, second derivative of g, negative x squared cosine x minus 4x sine x plus 2 cosine of x. And hopefully you have a little bit better understanding of how we can see and recognize when to use product rule, quotient rule, and in all the various different kinds of ways we could see it.